Good morning, and today we are taking a few ideas in mensuration. We'll study some cube, cylinder, cone, sphere, and so on. I first start with the cube actually. Let us study some properties of this cube, and this cube has got, say, all the three aspects like length, breadth, and height. All of them are equal, okay, and it's a three-dimensional one. And if I can spin this cube and show you, this has got a total of 6 faces, 4 lateral faces and 1 top and 1 at the base. So there are 6 faces. If you want to count the number of edges you've got, there are 12. You can understand that the edges here, you have these line segments, what you see here, there are 12. And if you want to count the vertices here, you have got 8 of them. They say all the corners, 1, 2, 3, 4 on the top, and there are 4 corners in the base. So there are 8 vertices and 6 faces. And also understand that there are 12 edges. There is Euler's formula which connects them, you get all the time 2. 8 plus 6 minus 12 equals 2. What do you have them? What are 8 here? 8 are vertices, okay. 6 are faces, vertices plus faces, and minus edges are 12. Okay, these line segments, there are 12. So you can see this now. If I explode that, okay, I just can separate them, and you can see now how it looks like. All the 4 lateral faces are squares. They're identical in nature, and there is 1 square on the top and 1 square at the bottom. So the total of 6 faces actually you have here, and I can join them once again. Okay, and I can make it completely transparent so that you can understand how it looks like. When I make it transparent here, you can understand this is how a cube looks like actually. All the corners you have here, 8 of them. And the line segments which form this cube, the edges, you got about 12 of them, and there are 6 faces actually. Okay, so the Euler's formula here, how do you apply this? 8 plus 6 minus 12 is 2. Okay, so it's all the time 2. This is about a cube. Okay, and you can make it even translucent. You can see this actually, partially allowing the light to pass through that. This is a translucent one. Okay, so this is what we mean by a cube. You can spin it, and you can understand that there are 6 faces. If you want to determine the lateral surface area, it is the area of 4 squares, 4 times a square. And if you want total surface area, it is 6 times a square, because there are total of 6 faces, 6 times a square. Okay, and all the 6 are squares, and area of each square is a square, 6a square. And if you want to determine the volume of this, it is side times side times side, or you can say edge times edge times edge, and that is a cube. Okay, so that is how you have the formula of this cube. Now I will take you to a solid figure where you have a pyramid. Okay, pyramid doesn't have a top. It is only a point where all these are going and meeting at one point actually. You have a base there. Okay, that's not a problem. You have a square base here, but all the lateral faces are triangles. Okay, this is the important aspect here. The lateral faces are all triangles. But if you want to determine the lateral surface area, you have to add up the area of 4 triangles here. How do you find out the area of a triangle? Half base times height. Okay, this is the base of the triangle. There is another triangle here. There is another triangle here. There is another triangle here. Half base times height. Height of this triangle is actually the slant height of this pyramid. Okay, that you should understand. So base times the slant height, half base times slant height. You have to do it repeatedly, Instead, you can do one thing: half perimeter of the base times the slant height. That is how you can determine the lateral surface area of this pyramid. And something I want to show you here. Here the base is a square. Okay. But you can start with another pyramid which has got only 3 sides. So I can make the base as a triangle. Okay. And all the lateral faces are triangles. And base also is a triangle here. Okay. And you got 4 sides then. You got a square pyramid. Base is a square. And you also can think of having 5 sides in the base. And that becomes a pentagonal pyramid. Okay, look at the base. Base has got 5 sides. How do you find out the lateral surface area? What is the formula for this? Sum of the areas of all these triangles you have perimeter of the base times the slant height. But if you add this area also, area of the base, you get total surface area. So this is a pyramid having 5 lateral surfaces. I mean, each one is a triangle. There are 5 triangles. Why do you have 5 lateral surfaces? Like, 5 triangles there? Because the base has got 5 sides. Okay. And you can think of a hexagonal base. Base has got 5 sides. So you can construct a formula similarly but in all the cases, remember, half of perimeter of the base times the slant height of this pyramid gives you the lateral surface area. And if you add the area of this base also, you get total surface area. Mind you, if you want to determine the volume of this pyramid, it is very easy. In fact, you should take 1/3 of area of the base, whatever you have, either 5 sides or 6 sides or whatsoever it is, but multiplied by the height. Height is not slant height, it is a vertical height. Means if you can draw a perpendicular from that vertex onto the base, and that becomes the height. So how do you determine the volume? 1/3 area of the base times the vertical height. So these are the 3 formulae you have. I repeat, as far as a pyramid is concerned, the lateral surface area is half perimeter of the base times the slant height. And if you want total surface area, lateral surface area, and you have to add the base area, that gives you the total surface area. And if you want to determine the volume of this pyramid, 1/3 area of the base times the vertical height. You can simply say height. So this is about a pyramid. I now move on to a prism. Okay. And you can say it's a prism and pyramid. They slightly differ. Here I have, say, a prism. This prism has got, say, 3 sides. I mean, it's a triangular base, and even the top is a triangle. Okay, but mind you, unlike a pyramid, the prism has got all the lateral surfaces are rectangles. Okay, this is a prism. Has got a triangular base. But mind you, I can increase the number of sides in the base. I can make it, say, a square prism. Prism means you got a top, you got a base, which are identical in nature. So I can vary the height of this prism now. I am reducing the height, I am increasing the height. Okay, and this is a right square prism. The word right is used here. Here the angle is 90 degrees. Okay, if you can observe there, the angle here is, this is not an oblique one. But this prism can become oblique, which you may not study here. Okay, and if you want an oblique one, and this prism, you can tilt like this. This is an oblique square prism, and it comes to this position as it is again. Now it is a right one. I don't want this oblique condition. Okay, only right square prism we have. How do you find out the areas for this particular prism? The lateral surfaces are rectangles. So each rectangle, that the base times height. Okay, if you can say this is the breadth times the height. And how many you have? 4 of them. So breadth times height and again breadth times height. Instead, you can say that perimeter of the base times the height. That is an easy way to remember. pH, perimeter of the base times height, because you are adding all the sides there in the base and multiplied by the height of the prism. So pH will give you the lateral surface area. If you want to determine the total surface area, you must add 1 square here and 1 square here. So you add 2 times the base area. Let me take another prism. Okay, it's a regular pentagonal prism. Let us understand. So if you want the lateral surface area, the simple formula you have is perimeter of the base times height, pH. It works here also. But how do you determine the total surface area? You must add the area of this pentagon on the top and this pentagon at the bottom. There are 2 pentagons. So base area, whatever you have, you double it, and that must be added to the lateral surface area. Lateral surface area, how do you get? Perimeter of the base times the vertical height here. We are not taking an oblique pentagonal prism. We are talking about only a right means here the angle is 90 degrees. Okay, fine. How do you get the volume? Any prism can give you the volume very easily. Base area times height. So here you determine the area of this pentagon and multiply it with the height. Base area times height will give you the volume of this prism. It's very easy to find out. I take you to another case, say right cylinder. Okay, you can see a right angle here. That tells you that it is a right cylinder. Okay, the height and the radius, they are perpendicular to each other. Okay, and I can vary the radius here. I also can change the height. Okay, this is what we mean by a right cylinder. And now say for example, I can make it say an oblique cylinder. An oblique cylinder means it's not a right cylinder. I can tilt it like this. I can just say, now the height is not perpendicular to the radius. This is an oblique cylinder. We don't study about it, and we study about this right cylinder. Okay, that's how you understand the word right there, because this angle is a right angle like. So now I can vary the height here, and I also can change the radius of that. Okay, and now let us talk about the properties of this cylinder like. Okay, and let me talk about the volume of a cylinder. And when you look at the volume of a cylinder, the formula here is pi r square h. Okay, now if you double the radius here, like it's 12 now. If I change the radius, understand that the volume becomes, say if you double the radius, volume becomes 4 times pi r square h. If r becomes 2r, the volume becomes 4 times pi r square h. And therefore, any increase in the radius, the square times you get the volume, pi r square h, pi times r times h. Okay, but if you make any changes in the height, if you double the height, volume also gets doubled. That's it. So now I am changing the height. So what you should understand is, if you want to increase the volume of the cylinder, you can change the radius or you can change the height. But you should understand, if you double the radius, volume becomes 4 times the previous volume. But if you double the height, volume becomes only double of the previous value. So this is how we understand the volume and how it is influenced by its dimensions, radius and height. Okay, and let us also talk about the surface areas like of a cylinder. And when you study the surface area of a cylinder, the lateral surface area is perimeter of the base times height. Perimeter of the base is a circle, and therefore the perimeter of that is like circumference of the circle, 2 pi r. 2 pi r times h, and that is the lateral surface area. Okay, it's a curved surface area. It is curved. And therefore, the curved surface area of a cylinder, the formula is 2 pi r times h. But if you want to find out the volume, it is pi r square h, base area times height. Now let us understand the two surface areas we talk about in case of a cylinder. The lateral surface area is 2 pi r h. Okay, you can change the radius. You can change the height also. In all the cases, how do you understand the surface area? 2 pi r h. But if you want to find out the total surface area, you must add one circle on the top and one circle at the bottom. So total surface area means twice the base area must be added to the curved surface area. Okay, so that is how you have two surface areas here. Curved surface area of a cylinder is 2 pi r h, but if you want total surface area, you add pi r square 2 times. So therefore, the result is 2 pi r h plus 2 pi r square. You can take out 2 pi r as a common factor, and that gives you 2 pi r times r plus h. So that is how we find out the surface areas of the cylinder. And volume of the cylinder, as we have seen a bit earlier, it is base area times height pi r square h. Let us understand about a sphere. A sphere is like a ball. Okay, and if you double the radius and volume becomes cube times that coefficient you are considering, like, so 2 times 2 times 2, so 8 times. So if you double the radius, volume becomes 8 times. Here the formula of volume of a sphere is 4/3 pi r cube. Okay, 4 on 3 pi r cube. So that is the volume of a sphere. And there is a significant change in the volume if you increase the radius here. Any little change in the increase in the volume significantly changes the volume. That's what you should understand. Okay, and what is the formula for the volume? 4/3 pi times r cube. This is the formula for the volume of a cylinder. But if you want to find out the surface area, okay, it is all curved surface, and 4 times pi r square is a simple formula you can remember, and you can increase the surface area, okay, by increasing the radius. But mind you, radius square you can find in the surface area of a sphere, 4 pi r square. Therefore, if you double the radius, volume increases 4 times. If you take 3 times the radius, volume increases, the surface area increases 9 times. Here, so surface area is 4 pi r square. So this is what you should remember. I can change the radius and I can increase the surface area, or I can decrease the surface area. But remember, if I double the radius, surface area increases 4 times. If you increase the radius 2 times, surface area increases 4 times. So that is what you have to remember. So volume of a sphere is 4/3 pi r cube, and the surface area, there is only one surface area for a sphere. It is 4 pi r square. So that is what you should remember. So these are the, the areas and volumes we have studied with regard to a cube. And then we studied a pyramid, we studied a prism, and then a cylinder, and finally we studied a sphere. So this is what we have for mensuration and formulae for surface areas and volume. Thank you very much.